Hopefully everybody can see the screen. I'll move around so I don't get in everybody's way all at once. So my name's Steve Whalley. I'm here to talk about sensors, but really I've spent the best part of my life at Intel. So if you've got questions on Intel and some of the things we did there, or feel free to ask. The agenda really is to talk a little bit about me, so you've got some background. But really, the bulk of the presentations is going to be on around MEMS or sensors, and then it's about you. It's a real privilege to be here. I've been involved with Gangplank since my daughter started working here, and I've met some really smart people, and there's some really good stuff going on. So it's a privilege and an honor to present to you and make it as interactive as you like. Feel free to stop me during the presentation. I will allow more time at the end. I'll try and get through this in 40 minutes or so, so there's plenty of Q&A time at the end. So with that, as Trish said, Jenny's dad. I come from England, if you can't tell already by the accent, and I am still a Manchester United fan. We were born in Manchester, so you're either a Blues fan or a Reds fan, and I decided to support United, and I've continued to do that. They're not doing too well this season, though. And then coming to the States, I had to get a new sport because soccer it was 23 years ago we came here. So I'm a season ticket holder with the Arizona Cardinals, and thankfully they're doing well over the last year or so. I started out in the UK working for an ASIC company, application-specific and integrated circuit. This is basically designing chips that start out fairly traditional, but you customize them for specific customers. And that was a fantastic job. I learned a lot doing that. That was kind of my apprenticeship, getting into semiconductors and CMOS and integrated circuits. So I spent a good number of years there doing design. And then went on to NEC Electronics in the UK to do a similar thing, but more in a management role, support role, and was probably there about, 3 years or so, before moving to Intel in the UK. Intel back, 23, 24 years ago was one of those companies that I think everybody that was in that field wanted to work for. They were pushing the microprocessors at that stage, the things called the 8080, which was one of the first 8-bit microprocessors, and the forerunner to what eventually became the 186, 286, 386, and the rest is history after that. So when I got the privilege of working for Intel, I was doing ASIC design and management there as well. And I did about 3 years there before they moved that function from the UK to Germany. And my wife didn't want to go to Germany. We had 2 young kids at the time. So I started working on something completely. I was in kind of the sales department for a while, but that lasted about 3 or 4 months. And the guy that had hired me was now over here in Chandler, Arizona at Intel. And we came over here, did a site visit and that kind of stuff with my wife. And decided to take a job out here. I thought it'd be like a 2-year assignment, just see how things go, but we've been here about 23 years now. And at Intel, I kind of worked on all the embedded controllers, 8, 16, 32-bit microcontrollers, from a product definition point of view, to a marketing, to a little bit of architecture. Got involved with the tools business, and then probably in the early 90s, I was running an 8-bit embedded controller group when some guys from Intel in Oregon came down and said, hey, we're thinking of building this new serial bus because the PC is a mess. When you want to add peripherals like a printer or a scanner or keyboard and mice, you had to go through a big hassle of setting DMAs, IRQs, you had to reboot the thing, you had to put floppy disks in. It was just a mess. For those of you who never lived through that, you're not missing anything, but it was a real pain. And what we wanted to do was have one connector that you could attach your mice, your keyboard, printers, cameras, whatever, and that was the start of USB. So there was about 6 of us on the initial team. I was building silicon for the peripheral side of the world, and the guys from Oregon were doing the chipsets that would go onto every PC. So that was my early, or actually my first initiation on doing industry initiatives, because that involved working with a Microsoft, a Compaq, IBM, a few others. There's about 6 companies that with a kind of lead on the definition. Although Intel did most of the work. And then from there, I worked on other things. I've worked on PCI Express, which is another I/O kind of initiative, but also things like security, wireless, power management, UPnP, Universal Plug and Play, and a few other things. I guess before I left Intel, I was, so the last 4 years, was because I recently retired, or semi-retired from Intel about June the 10th actually, so not long ago, about a month ago, and the last 4 years there was spent on sensors and MEMS. So Intel doesn't build them, they use them in their platforms for phones, tablets, and PCs. And again, we don't actually manufacture the end products in those devices. It's really about building a platform and then giving it to an ODM or an OEM that they go off and build it for an IBM, a Compaq, a Samsung, Apple even. And so in order to understand how to build those platforms, you really need to understand all the technologies on that particular platform, from the microprocessor itself to the I/O technology to the graphics engine to the displays and to all the sensors that were now starting to appear. So that really is the lead-in to the rest of the presentation, really, because I got pretty heavily involved in the sensor work at Intel, driving the strategy to get that going, and then I've worked with a number of companies in the industry as well that actually build sensors. So now I'm kind of part-time. I do 3 days a week with the MEMS industry group, which is an industry body that basically looks after the supply chain for the whole industry of MEMS and sensors, which is basically everything from fabs, manufacturing, design of sensors, all the way through to the integrators and the end users that put them into real products. So what is MEMS? Micro electromechanical system. So when I was involved at Intel, we were building big CMOS circuits, 3-4 billion transistors that went to make up an i3, an i5, or an i7 type of microprocessor. And then when I got involved, I started seeing these circuits that have moving parts. Literally, these are very complex devices, totally different than a normal microprocessor. And in order for them to work, you actually have moving parts. You have things like that actually going in and out. I don't know whether you can see it on this particular device here. So it's hard to see, I know, on this screen, but that's what a real device looks like. You actually have things moving in and out, changing the capacitance levels of something, or effectively acting like a spring for an accelerometer. So one of the key components of a MEMS device, or the one of most widely used, that everybody. Okay, it's still working. So one of the key components that everybody has in their cell phone is an accelerometer. And the accelerometer is the thing that basically switches from portrait to landscape. So when you move the phone from landscape mode to portrait mode, it's the accelerometer that is detecting whether you're in the XYZ position or maybe in the vertical Z position, XY or Z position. And essentially what it is this thing down here where you have a mass and a spring, and as things move, if you imagine a spring with a mass on the end of it, obviously as motion goes in one direction, the mass may go in the opposite direction. And imagine that on a three-way, what we call a three-axis approach, where you can actually detect motion and acceleration in the X, Y, and Z positions. And those are all standard components now on a cell phone, as an example. But it's not done with, obviously big part. This is the actual dye photograph of what an accelerometer looks like. And just say where this little thing is down here, that's actually 10 microns, 10 micrometers in dimension there. So they're very small devices. And then, like I said, accelerometer is the basic component, but then other devices that are manufactured in this manner are typical things like a gyro that measures rotation, and a magnetometer, say, or compass that would measure heading. And those three components are essential for when you're doing, say, navigation. So we all use our phone now to get from one place to another. Sometimes we rely on GPS signals from satellites. But within a building where you don't have satellite coverage, you need to rely more on your MEMS and your sensor devices to actually fix your location and get from one place to another.
Quick question.
Sure.
The MEMS devices are primarily as sensors as opposed to doing things. Are there any that actually?
That's a good lead-in. So the question is, are they primarily sensors, or do they actually do things? Do they have outputs as well? Can they be switches or actuators? And yes, they can. So this slide actually gives you some idea of the range of types of devices. So a lot of microphones now are going from the old electrostatic analog microphones to becoming more digital, and they're built on MEMS devices. So pure digital form of a microphone, and you can actually do that with a speaker now as well. So very small micro speakers are built using MEMS technology. We talked a little bit about all the motion and the positioning of accelerometers, gyros, magnetometers, and then inertial navigation systems. And a lot of these were born in the military days. Aircraft, obviously, military devices all use these type of devices. Obviously, we've made them a lot smaller now to go into things like consumer electronics. Pressure monitoring. So most people with a reasonably new car have pressure tire monitors that tell you, when they need inflating, etc. That's a MEMS device. So it actually measures the pressure. And the neat thing about those things is they don't require a battery. Obviously, you don't want to be changing your battery in your tires. So they run off energy harvesting. So they actually power themselves over a period of time. And then things like displays. So Texas Instruments are one of the big suppliers of the mirrors that go up to make projection TVs. Obviously very popular before the days of LCD and plasma, but are still popular today in some very small micro devices. So I don't know whether you can plug a device into your cell phone to now and have that be your overhead projector, and that's using a MEMS device for the display. And then some of the functions where you start to get more functionality coming out of the device and taking action are the resonators and switches, kind of electronic equivalent of relays, and then microfluidics as well. So one of the big users of MEMS is inkjet printers. So on an inkjet where you need to very specifically squirt ink, very defined, that is a microfluidic MEMS device. And they're also used in the healthcare industry, which I'll talk a little bit about it as well. And then we go on to biosensors for wellness, sports, health activities, which we'll talk a little bit about. And then we're getting even smaller. So there's we call MEMS, which is micro, and there's now NEMS, nano, as we go 10 to the minus 9 meters in dimensions to get to even smaller geometries as well. So that gives you a range, and I'll dig a little bit deeper into some of these as we go through. This is the bulk of the market at the moment where MEMS are being used. Essentially, the whole market took. I mentioned that the military, industrial, the automotive industry were using them for air pressure sensors on tires, but they were also using them for airbags. So the MEMS device would detect an impact and deploy the airbag. But the volumes were relatively, small. A few million devices a year. And it wasn't until things like the Wii and other game controllers started to use them for positioning and actually detecting motion from your arm, etc. And the big one was Apple. So Apple started to put MEMS and sensors into their iPhones in 2007. And then the whole market started to take off, because what Apple did, all the other cell phone manufacturers had to do. And then over time, it's just grown. Like I said, inkjet printers are a big user. Earbuds, the MEMS earphones I mentioned, and obviously things like tablets and PCs are now using them. And then we got a whole class of wearables now. Wearables for your wrist. Again, basically a pedometer that is measure motion and tracking your number of steps. The Basis watch here. It does all the same functions, but it also has an optical sensor on the back of the watch that detects the blood flow, so it can measure your heart rate fairly easily, and also does a good job of sleep monitoring. And then Google Glass as well. So there's half a dozen or so sensors in Google Glass to measure motion and various other things. So this is the consumer electronics industry, really, which is now starting to drive the volume in these devices very heavily. I won't spend time on this. It's an analyst chart, but we're looking at 2013. It was about a $9 billion business just for the sensors themselves, and growing at twice the rate of the CMOS semiconductor industry, which is not always a bad growth either. So. That's the size of the market. The types of industries that are using them are the consumer and mobile markets, obviously, automotive, and then the other ones are emerging or just a little bit nascent at the moment as well. Just a quick one on the types of companies. So the race to be number one has always been between kind of Bosch, who started out very heavily in the automotive business and now have moved into consumer electronics, and ST Micro. Those two kind of switched number one and two over the years. Texas Instruments are very big because of their displays. Hewlett-Packard are very big because of their printer involvement here, and then the rest goes on and on. And now there's a number of, some of these companies, to the right of the chart are obviously fairly big names. But they're getting more into the MEMS business as sensors become more useful and required on a lot of devices now. Okay. So one other thing to mention is, as well as the MEMS device, the actual sensor, a key component in making this come to life is the software. And there's a couple of things to mention here. When you have a lot of sensors providing data to your main application processor, it can very easily drain the battery life. So if I'm using my phone to navigate, throughout the day in my car or wherever I'm walking to, or on a bike or whatever, and then I'm using it for other sensory applications, the battery would probably only last about 2 days if those sensors were connected directly to that. Sorry, the battery would only last about 2 hours if the sensors were connected directly to the main application processor. So what we do instead is have a little microcontroller, which we now call a sensor hub, that is usually a 16 or a 32-bit device that performs all the algorithm functions or runs the algorithms to make sense of the data, because the data coming from an accelerometer or a gyro is just a lot of XYZ coordinates. How do I turn that into I'm heading north and I'm walking at 5 miles an hour, or I'm driving at 50 miles an hour, whatever. So the software industry is a big component of how these things work, and writing algorithms to interpret the data, make sense of them, like the Fitbit or the Fuel Band. How does it know exactly what I'm doing in terms of walking, running? Am I sitting? What's happening when I'm sleeping? Is it a light sleep, a deep sleep? How many times did I get up in the night? All that is your algorithms, and that all runs on a microcontroller, and you keep the main application processor asleep probably 99% of the time. And that conserves battery life. So the sensor hub and the algorithms are two of the big elements that we worked on at Intel, and go hand in hand to support the main work of the sensor devices. Oh, before I go on to this slide, any idea how many MEMS devices or sensors you have in a smartphone today? 14? Good, good. You're in the right ballpark. So it's anywhere from about a dozen to about 18 or 20. That's today. And it ranges from all your microphones. You have multiple microphones now in a cell phone. You have CMOS imaging devices, the camera, multiple cameras. And obviously you've got all the inertial sensors. You've got pressure sensors, humidity sensors in some phones now, and more coming. And then you've got actuators as well. So the thing that actually, when your phone's on vibrate, that's a device that is a MEMS device, haptic device that gives you some output.
Right now, are most of these integrated into the processor, or are they
separate? So the question is, are these integrated into the processor, or are they separate devices? Most of them are all separate devices at the moment. The MEMS technology and the processor technology are very divergent. One is, kind of 22 nanometer CMOS, very, very expensive to build on a CMOS process, and the MEMS technology is on a slightly older technology, really, and the technologies don't go hand in hand. And so that's one explanation why they're not all integrated together. The other explanation is some of these devices have to be separated on the actual motherboard as well, because you want an accelerometer in, say, the center of gravity of a cell phone or whatever device is, and you may want your gyro or mag obviously away from speakers or away from the center of gravity of the device. So there's various reasons why you place different things in different areas, but that all goes to say they need to be discrete components, really. Now it's a good lead in, because there is a few companies now that are starting to integrate the sensors themselves, so you can have an accelerometer, a gyro, and a magnetometer together. It's what we call a 9-axis combo inertial measurement unit, IMU. And so those are becoming more popular now. One is to get the cost down, and one, it makes it easier to assemble. So we have about a dozen to 18 sensors in a typical smartphone today. And then this is kind of a smartphone of about 2017 era, where you start to add things like the Pico projector. You've got those today, but they're just a plug-in device. But in the next 3 years or so, the size, power consumption, and cost are coming down, where that could be integrated straight onto the phone and be used your phone directly as a projector. There'll be more biosensors, so like gas detection, alcohol detection you can do on your phone fairly easily. But
can you tell you what an X bar is? That kind of alcohol?
Yeah, that type of, not the other gas, but the so alcohol detection, just things like bad breath. You can detect how is your breath today. And again, these devices kind of exist, but they're either in hospitals, clinics, or they're huge. But with the MEMS devices now, they're all coming down to fairly small and reasonable cost. That you'll start to see a lot of these getting onto phones. So Samsung is, I would say, the leader in this. They integrate more of these newer sensors than anybody, but others are following, and I think you'll see Apple do more in the future as well. So that's one of the big drivers, obviously, of very high volumes when you get some of these sensors into the phones. So we've talked a little bit about some of the typical consumer electronics devices. I also wanted to show you some other applications. So this is the MIT Media Lab over in East Coast, Boston area. And they do a lot of work on sensing capabilities, a lot of different sensors. And what they've done in their actual building, they put sensors everywhere that measure humidity, temperature, human presence, noise, CO2, and a variety of other things. And what they allow you to do is actually go in and see this thing at work. So if I can pull up a web page here, if this works, maybe it's not. So it's gonna, I don't know what, yeah, I was thinking of just going in and actually doing a very interactive demo of, moving around this building, seeing what type of sensors, and it's real time. I mean, I'll show you, temperatures, people moving around. It also tracks audio, but it actually encrypts the audio. So they're not actually snooping on people and listening to their conversations, but you get an idea for the intensity of speech and volumes. And I guess I'm not getting a web.
Are you connected to
I was connected, yeah. So anyway, maybe we can try that at the end if we have time. The other thing was, so they've done, so you'll see that a lot more in buildings. 40% of the energy consumption out of the US goes into buildings. I think it's 40% energy into buildings, 40% into industrial use, and the other remainder, 20% or so, is transport. So energy conservation in buildings is becoming absolutely critical these days with the high cost. This is another thing they do. This is Tidmarsh Observatory, which is kind of an area where they put sensors throughout the marshes, which is actually giving you noise of the animals and the birds. It's measuring the changes in temperature. So over time, it will obviously give you data on any climate changes. And again, you can go into this real time. So if we don't get it to work today, at the end, just go to the MIT Media Lab, and you'll find these presentations, and they're pretty fascinating to go into real time and see what's going on in some of these areas. So moving on, so just quickly, some of the driving forces on what's going to happen to push the next wave of sensors are a few things here. Technology, medical, and social. So the social aspect is an interesting one. If you've heard of the quantified self movement, people have been basically measuring things and tracking things for decades, but just basically doing it manually. They've been writing it down. They've been taking their body temperatures. They've been, doing all sorts of things to see how behavior changes those measurements. Well, now you have a lot of devices like Fitbits, fuel bands, watches, etc., with more sensors, your cell phone, that can do a lot of that for you automatically. So that is a driving force where people are now saying, hey, if I had this type of sensor, I'd be able to keep better track of my healthcare issues. The technology obviously is driving it as well. As things have become smaller, lower power, everything's going wireless, and everything is becoming connected. We've all heard of the Internet of Things and how these all things get connected these days. Well, that's a big driving force as to how that drives the next generation of sensors. And from a medical perspective, we're seeing a lot of the devices that were once in hospitals and clinics make their way now to cell phones and plug-in devices or add-on devices that are becoming key to driving how we monitor what's going on in our body. What is my blood pressure? What is my heart rate today? And how does that vary over time? What happens when I get stressed? What is stress? How do I measure that? So there's a number of things now that you can measure very easily with some of these components that would, fit on your arm or actually become part of your clothing. And that's happening in the car as well. So there'll be a day when you can basically leave home in the morning, drive to the office, and by the time you've got to the office, all the sensors in your vehicle, in the seat, in the dashboard, on the steering wheel, will have taken all your vital signs. So you get to the office, that's already been automatically uploaded to your smartphone or tablet PC, and you've got a reading for the day, and you can see how that varies over time. It's not going to replace doctors, but it's going to give the doctors a lot more data to go on, versus walking in a doctor's office once or twice a year and them having to ask you a lot of questions. What have you been doing? You've now got a lot of data that you can go in with and give the doctor a lot more help in trying to diagnose what's going on. So this is, I think, a big area that you'll see happening over the next few years. It's starting to happen today, in fact. So these are a lot of sensors now that are becoming available. So ECG for heart rate it's very easy to do. In fact, I had a clip-on case to the back of my phone, this one. That's just basically got 2 electrodes, and that, you put your hands on that, and that measures your heart rate and gives you all the waveforms, and it, basically shows when your heart valves are opening and closing. And the cardiologist that designed that says he basically diagnose 80% of the heart conditions just with that simple device. It's a $200 device that is a cell phone case, versus doing a 12-lead ECG. A whole range of other things of ways of measuring your heartbeat. EMG is a electromyography system, and that measures changes in muscle. And again, I have a video on this one which I don't think is going to work, but I can try play it at the end. If you've not seen it, there's a device called MYO, M-Y-O, from Thalmic Labs. It's basically an armband that allows you to control certain, like a hyperlink in, oh, yeah. I don't know whether you caught all that, but that's a device it's a $199 device. It's coming out in September. It's already out there for developers. And basically, it just allows you to do different gestures. You can, you program it. You do certain things with your fingers or twist things, and you can control presentations. You can control video on and off, fast forward, etc. on Google Glass or whatever. A really cool device. And that's just using, there's muscle sensors in there and accelerometers and gyros as we talked about. So I guess I could go back to the other presentations in a bit and do them. So that was EMG devices, and there's a range there. EEG is more for brainwave detection. So there's a number of devices now using sensors in, essentially headsets where you can start to control things with mind. That's a little bit more futuristic, but it actually works. We've tried a few of these things at Intel, and there's a lot of, again, there's commercial products now you can buy that were once big equipment in labs, but are now becoming headsets that you buy for a couple of $100s or so. Sweat detection and hydration. At Intel, we were on the road talking to various sensor manufacturers for a couple of years, and the one thing that we never came across was a hydration sensor. Being in Arizona, you would think, wow, wouldn't it be great if there was something that tells you, drink more water, or you're becoming hydrated, start drinking. And that's a little bit more difficult to do. Normally they do it with saliva, so they have to take a saliva sample. But there's easier and easier ways of doing that now. So I think we'll start to see more of that, which is very important for children, as well as elderly people in care homes, etc. I don't know whether you saw the Google Glass thing, not Google Glass, the Google contact lens. But that can measure blood sugar level now, and again, it's still reasonably in research, going to development, and maybe becomes a product in the next 5 years or so. But being able to, if you're a diabetic, very easily detecting what your sugar levels are and how much insulin you may need. And then breath. So again, alcohol detection, bad breath. The top one there is forget the name. It's a company that was spun out of ASU, and they do metabolism. That's the word I was looking for. So they, mainly for sports users, but what's your metabolism over a period of time? How does that vary with races, etc. And obviously, for those of you who know Chris, asthma detectors. What is my breathing condition today? And so there's one or two out there. Nothing on the level that Chris Stifler was working on. He was definitely ahead of his time on that one. But a lot of people starting to look at that area as well. So you can see in the healthcare industry and making it more personal that there's going to be a lot of uses coming very, very soon. And then on the environmental side, obviously measuring indoor and outdoor air quality is important. One of the things we had at Intel was a migraine detector. So it was a series of sensors that could be on a phone or it could be on a key fob that would measure air quality, CO2, it would tell you the humidity, the pressure, and you'd start to build up a picture, and then you could basically say, oh, interesting, I'm tracking this, and every time I get a migraine, these conditions are prevalent. It's high humidity, high pressure, it's a noisy environment, whatever it is. And so you start to build up a picture, and then your key fob or your phone could give you an alert that maybe in 3 hours from now you're likely to get a migraine if you don't take evasive action. And the same thing could be done for stress or potentially asthma as well. And we're able to do this now with food quality monitoring as well. So having a little device that you go into a produce store with that would tell you, are the bananas or the fruit ripe, or is it going off? They emit a certain gas when food is going off, and it's very easy to do a detector of that and say, oh no, let's pass on that because there's not going to be much shelf life in it. Okay, so trying to wrap up so allow some time for Q&A. So we're seeing obviously a lot of innovation now in wearables. I don't think you make a wearable device these days without some kind of MEMS or sensor capability in it. Seems like everything going mobile is going to have sensors in it. But then as you look at the Internet of Things with smart cars, smart cities, buildings, even farms now are putting a lot of sensors in the soil to measure moisture, soil quality even. And even on the crops themselves, sampling every, especially in a winery, a vineyard where you want to measure, the exact time when you want to pick those grapes. There's a lot of sensors that are helping to do that. We've talked a lot about the healthcare industry. They're going to use it big. Robots are coming. They're already here, obviously, in many areas, but you'll see more robots. And a typical robot today has like 100 MEMS sensors on it. And then people. I think it's all about us at the end of the day, and getting these things to work for us. But having some sensors to help us along the way are going to be needed. And my vision is, instead of having to put a new wristband on or Google Glass or whatever, you'll just get dressed in the morning. Your clothing will have embedded sensors in them. It's very easy to build textiles now that can measure certain things. A lot of the vital signs could be done very easily. And again, there's already companies starting to do this. So wouldn't it be easy if you just got dressed in the morning? You don't have to worry about where the sensors are. And like I said, by the time you get to work, you've already taken your vital signs for the day, and any alerts come to what might be going wrong. I don't think Jenna's here today, is she? But I had a sensor thing for her as well. So this is Mavericks. But there are sensors now that you can put on surfboards and even skateboards. So I don't know whether you caught all that, but that's basically a device that just attaches to your surfboard and can measure wave height, acceleration, direction, various other things, and then you can start sharing that and build up a picture of people you maybe want to compete with. Surfing is a little bit, surfing's a little bit like fishing. When you catch a fish, the fish was this big. And same with the waves. It was a 6-foot wave, but it was really, it was 12 foot that day. With this device, it's kind of measured the actual height of the wave as well. So just wrapping up here, the title of this talk was Sensors Everywhere. So I think we've shown that sensors are going everywhere, but is it a noble cause, necessity, or a menace? Well, the answer is yes. It's all the above. But the menace part we haven't got into just because of time. If you think about it, there's a lot of this data now flowing around, and it's not just your bank data. It's your personal records, your health records, maybe even your DNA sequence that is being uploaded to the cloud and shared and put on social media, etc. And unless we do something about the security side of it, then there's going to be issues. I mean, one example is a glucose monitor, an insulin a glucose monitor that basically tells a diabetic how much insulin they need. Well, they have been hacked into. So you can actually kill somebody by telling them, a different type of insulin dose is needed when they don't need it, or vice versa. So there's a lot of work going on the sensor security, and somewhat related is sensor privacy as well. Who do I want to share this data with? But that's probably the topic for another day if you're interested, because it would take up a whole day if we wanted to talk about that. So finally, if you want to learn more, there is the memsindusтрygroup.org, where there's a lot of tutorials on there, webinars that have been done. There is a conference coming up in November here in Scottsdale. I think it's a 2-day thing where you can actually meet the industry, meet the players in the industry. You can actually submit products as well. They have a tech showcase where if you have a product that uses MEMS or sensors that you want to come and demonstrate, then submit that. You get into the conference obviously for free. There's venture capital there. There's people that would help give you peer review of your product, maybe help you with marketing, sales, etc. So it's a worthwhile event if you're interested. And with that, I'll take some questions if we have time. Yeah, can do. You have any questions, or shall I go back to the MIT?
Unless anybody wants to go back to the MIT. About a lot of what you're talking about is lots of sensors, and right now there's a lot of sensors I can buy that are one-off, whether it's a temperature control, and it's got an enclosure, it's got to have a battery, and all those. And what I'm wondering, maybe hoping for, is sensors that are not integrated part of things, but small enough that they stand alone, and all they do is report data to somewhere. And I haven't heard anything about going in that direction, and I was just curious if you had any comments.
Yeah. So the question is, there's a lot of sensors and there's a lot of things that are connected to them. What about just a node that would be measuring things and then reporting that data? Well, that's essentially is happening in what we call wireless sensor networks. And that could be deployed in, say, a field, an agricultural situation, where you're collecting, temperature, humidity, rainfall, whatever, and then you just report that back for different parts of the field. So the communication part in all of these is key. And combining the sensors with wireless communications, either Wi-Fi or 3G, 4G, Bluetooth is happening as well.
And I have several of them, but the problem is that they're, they have to be huge products.
Yeah.
Enclosures and all that. And I didn't know if Intel or the industry was specifying anything that was going in the direction of being standalone, self-powered, or.
Yeah. So there's a lot of work going on to try and make these obviously smaller, lower cost, and more importantly, lower power. Really, to really. Or I'll get to the point where it's zero power, where essentially you do energy harvesting. So depending on the situation you're in, if you're in an outside environment, maybe you can have a small solar cell that is driving the device. If you're in an industrial application, some of these sensors are mounted on pipes that vibrate, and just the vibration of the pipe is able to monitor them, to power them. And then, with cell phones, we haven't got down to the power levels yet. But the fact that you are walking around with your phone, swinging it, and that is generating power, essentially. Now, it's not enough to power your phone, but over time, it will, provide some kind of, boost to certain devices. It might not be a phone. It might be a communications device that is dedicated to a certain function. But, the power levels are not there yet in all these devices, but that's the goal of where everybody's going.
I've got some friends at UVI in Champaign-Urbana, and they're talking with some people in Chicago, and there's some kind of interface going on with Samsung about the technology that they think will be out like 2025, 2028, that basically they'll do these subdermal devices, kind of like the old, like the pill stuff you used to be.
Yeah.
Subdermal pills, but they're the MEM devices, but very small devices, usually two in the body, one in the upper part, one in the lower part, in the armpit or inside the groin, but you want top and bottom. And those units, through the moisture in the surface of the entire body, except for hair and except for nails, for some reason they can't quite figure out the mucous membrane of the mouth area. But aside from that, they're able to do all kinds of things, sense all kinds of things from the body. They said, they look at Google Glass and Google Contacts, and they said they laugh because they say, no, we're going to be sending signals. They'll be able to, these sensors will know precisely to this extraordinarily small position, the position in front of your eyeballs, and they basically project on the liquid in your body, on the surface of your eyeballs, whatever image you want in stereo.
Yeah.
Okay, and these units they can also put either in the nervous system or inside the ears, provide the audio and no more earbuds, that whole kind of a deal. And they said they can change everything. You're sitting a long time in a chair and your butt is hot. They can adjust it so your butt isn't quite so hot.
Yeah.
Let alone all the stuff attached to other devices like your car and stuff. Have you heard about stuff?
Yeah, in fact, the MIT Media Lab is a great, I toured that place about a year ago now and got to see some of that, not just the sensor lab, but some of the other medical labs that they have there. And there's a lot of work going on in kind of intravenous pills that stay in your body and give you all sorts of medical data. But there's patches now that either go directly on the skin, just like a Band-Aid, or could go just slightly under the skin. At Intel, we were trying to keep away from that. We wanted to go non-invasive. So for us, a watch was great because you just put a watch on, and with optical sensors, you shine through the skin into the blood, and then you can measure a lot of data just through that. But as you go into the body, then you get more data. But the fact is, these devices tend to be like 30 days at the most, or less, and then you have to replace them. But there's a lot of, one of the great things I saw at MIT was microfluidics, which is a MEMS device. A little bit like an inkjet printer, squirting ink out. But this actually measures blood flow and can detect cancer cells and basically send the good cells in your blood one way down a path and the bad cells, the cancerous cells, down another. That is kind of being shown today in a research project. Hopefully that comes out in the next 5-10 years, and you can start to filter your blood and get rid of some of the bad stuff. But yeah, it's happening. But unfortunately, some of it's just research, and it is 10 years away. Sorry, you had a question? Oh, good question. I don't know. The only thing I would do is just distributors. A lot of the sensors are off the shelf. Obviously accelerometers, gyros, mags, etc. You can get very standard ones that go into cell phones today off the shelf, and the only place I would suggest is just going to the local distributor, or just online as well. But over time, what people find is they want to design their own sensors. They become very customized, especially if you're in the healthcare business. And there's a ton of companies that will help you all that. They'll do the design. They'll find a fab and make you 100 devices, and then if it obviously takes off, you can go into a higher volume fab as well. But I would say just your local distributor is the best place to start to do some of that initial work. For those that have time, I can try and go back to the question about the MIT lab and. It's trying to load the data. There's a lot of data that is being assembled, and that's probably taking time. But I don't know why, because it was pretty quick when I tried it this morning. Any other questions while we're waiting? You can try this one online as well yourself.
How's the technology coming along to make sensors out of dissolvable components for in the body, doing maybe taking pictures and then the procedure be less invasive for high risk patients?
It's slower. I have seen a few commercial devices that obviously there are the pills that have cameras in them, and basically they just flush out at the end of the day and go through your digestive tract. There are some that basically just do very basic things like, what have you eaten and what type of foods are you having and have you taken your medication? That's an intravenous pill that people use. The big problem I found talking to some of the healthcare industry is that when they do trials or even when they just give patients pills, they don't take them. And they want data to really know that versus trying to rely on the patient themselves to tell them things. So it's further away than some of the things I've talked about today. So I would say it's probably in the 5-10 year range of getting those. No, it's not too long. But some of these are in the 0 to 5 year time frame today. There's a lot of good work going on. That's a good thing, I guess. And it's helped by the consumer electronics industry. Smartphones and Wii's, etc., inkjet printers are really helping the healthcare industry drive the cost down, and making the DNA sequencing that there's a goal to get DNA sequencing down to $1,000 per sequence. It's $10,000 at the moment if you wanted to have your DNA really done well. And it's approaching that. There are companies that are getting very close to $1,000 per use of it. But that could come down to $100 eventually as well. And once you know that, then once we've got very specific DNA sequences, then you can diagnose a particular treatment for a particular cancer, say. For most people today, if you have breast cancer, then you get a standard, reasonably standard treatment. I mean, it does vary. I don't want to paint too bleak a picture. But if the doctor really knows, specifically what's going on in your body, then you can tailor the treatment a lot more effectively for many diseases, not just cancer. This thing is it's taking time to load for some reason, so it's not. That one's any easier. Yeah. So, like I said, go to the MIT Media Lab, and you'll see the sensor lab probably underneath that somewhere, and you can see these 2 videos or interact with the presentation. Okay, thanks for your time.